Hi. So you were right that this is very similar to a problem that you asked me earlier, and I have it right above here. It was a question. I think this was it right here. Cosine of 2 theta equals sine of theta. And to work through this problem, the double angle identity that we needed to use for cosine of 2 theta was 1 minus 2 sine squared of theta. And the reason I chose that identity for substitution is that I wanted to have, it's not the same variable, that's not the right word, but the same unit here where I had sine and sine. I didn't want to have sine and cosine. And the reason I chose this one and I wanted to have sine and sine is because then I could do a substitution. And that made it easier to work with as a polynomial. And not necessary, you don't have to do that substitution, but it made it a lot easier to kind of visualize what we were doing and connect it to previous learned skills that we have, where we have a polynomial in this form. So I'm going to look at the same type of thing for this question. This was the one that you posted. There was a stipulation with this problem that wasn't in the last problem, and there was a domain here that said that alpha is in between 0 and 2 pi, inclusive of 0. So we're including 0 in that, but we are not including 2 pi. So if you remember your unit circle, 0 is included. And if we go all the way around the circle, but not quite finish, because if you finish the circle, if you complete a full rotation on that circle, you're going a full 2 pi rotations. Remember, halfway around the circle is a pi radian. All the way around the circle is 2 pi radians. We're not quite completing that circle. With the unit circle, I'll remind you here, and I'll say it again at the end, cosine is represented with the x, sine is represented with the y. There's more to that, but I'm gonna breeze or pass over that. Here we go. Okay, we've got a double angle here, 2 alpha, and we've got an alpha here, so that doesn't help us. But the 2 alpha, we can make a substitution. There are a couple of different double angle formulas, and this is in Newton. I just didn't take the time this time to find that lesson and pull up that the instruction from Newton exactly. But this is in the notes from Newton. So cosine of 2 theta has 1, 2, 3 different substitutions that are used or that can be used. And they're all basically the same thing, just rearranged in different ways depending on your needs. Since we need cosine to stay cosine, I'm going to choose 2 cosine squared theta minus 1. I'm not going to choose the one that has sine and cosine because that wouldn't be as helpful in solving this problem. And I wouldn't choose the one with sine in this case because, again, I want to keep with cosine if I can. So I'm going to replace this, and I'm going to make a substitution. It's going to be 2. That 2 right here stays there. I haven't changed that coefficient. And I'm going to make the substitution. Cosine of 2 theta is going to become 2 cosine squared theta minus 1. 2 cosine, I'll put it here, squared. And of course, they didn't use theta, they used alpha in this case, but same idea. Just a different variable. Plus, you can see, or you can, I don't know if you can hear my kids playing in the background, but hopefully you can't. Equals 0. All right, so I made that that substitution for the double angle identity. I'm going to distribute through those parentheses. And you might be able to see where this is going since I kind of mentioned the polynomial idea earlier. I can type it up here, minus 6 equals 0. And by combining some like terms, and I'm actually, so I'm gonna combine the negative 2, the minus 2, and the minus 6 together. That'd be minus 8. And then I'm gonna factor out a 4. And I'll let you kind of follow that along on your own to see where you end up with it. But I'm gonna end up with that. There we go. So again, minus 2 minus 6 is minus 8. If I factor out a 4, and then 4 from the minus 8, I'm going to end up with this. I'm going to do the same type of thing as I did before. I'm going to make a substitution. And this isn't necessary, but it's helpful for me at least, and for most people, I think, to see it as just a variable, not as a cosine. But I'm going to say that u is the same as, I don't know why we always choose u. It could be anything. It could be lightning bolt equals cosine alpha. It doesn't really matter. For whatever reason, we call it a u substitution, and we use u. What I'm left with is 4 u squared plus u, I lost it here, u squared, there we go, plus u minus 2 equals 0. So I'm making that substitution. It looks more like a polynomial that we're comfortable with, and I can start addressing this. There's an equal sign, which means I can solve this for u. I can divide both sides by 4. The only benefit of that is it leaves me with less stuff to worry about. If I divide by 4 from both sides of that equal sign, which I can do by the division property of equality, I just get u squared plus u minus 2 equals 0. One less thing to worry about, that 4 is more or less not important because I was able to divide it away, and 0 divided by 4 is still 0. I'm going to factor this. You don't have to factor it. You could use the quadratic formula or the quadratic formula. You could use completing the square. There's lots of ways that you could do this. I'm going to factor. And I'm going to get that u plus 2 times u minus 1 equals 0. So if you FOILed this out, you would end up back at where we started here. So that's my factoring. By using the zero product property of a quadratic, I can say that either u plus 2 equals 0 or u minus 1 equals 0. One of them has to be 0 for the product to be 0. So if u plus 2 equals 0, I guess I can write this out. U plus, there we go, u plus 2 equals 0 or u minus 1 equals 0. If that's true, then either u equals negative 2 or u equals 1. I'm going to go back to that picture of a unit circle. Again, we're looking for either that u is negative 2 or u is 1. And maybe before I go back to the unit circle, let me replace u. I'm going to use this equality that I established earlier to say that the cosine of alpha either equals, the parentheses are just a notation that can be dropped or kept. So don't worry too much about the notation with the parentheses. But I'll leave it in here just to distinguish it. There we go. Equals 1. Okay, so either the cosine of alpha equals negative 2 or the cosine of alpha equals 1. One or the other. Those are the only two options. If we go back to that unit circle, cosine is represented with the x here. We never, ever, 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 ever get to negative 2. We get to negative 1 and back up to 1 and back down to negative 1 and back up to 1. And it oscillates, if you remember the graph, between 1 and negative 1. The only way to change that is to have a scale factor in front of cosine. If there was a 2 in front of cosine, 2 cosine of alpha, then it would oscillate between negative 2 and positive 2. Since there isn't that 2, we're never going to get this. This is never going to happen. Cosine of alpha will never equal negative 2. I think there's even a, there we go. It's not going to equal negative 2. Won't happen. Not possible. So we just need to look at when cosine of alpha is equal to 1. Cosine of alpha equals to 1 at 0 and at 2 pi and 4 pi and 6 pi and 8 pi. Every 2 pi circle, every 2 pi radians around the circle, we get back to the cosine being 1. However, looking back at the original problem, there was a domain stipulation here. The domain said alpha is only between 0 and negative 2, inclusive of 0, but not inclusive of 2 pi. Sorry, I said 0 and -2, 0 and 2 pi. But we're not including 2 pi, so we're not going to get that full rotation around the circle. Which means that the only time that this is going to be the case, that this is going to equal 0, that this original equation here is going to equal 0, is when alpha equals 0. When alpha equals 2 pi, this will also work, but that wasn't part of the domain. So it's only when alpha equals 0. Hopefully that helps you, both in terms of choosing which double angle formula to use for that substitution, and then another refresher on how to make that substitution here to form a polynomial. That can be very helpful in solving these problems. It sounds like a couple of them are popping up where you need to make that substitution, create a polynomial, factor it, and then find those two different solutions, potentially. It could be that there isn't a second one. Keep going back to that unit circle. Again, I just keep Googling unit circle. Here's that picture. So you don't have to memorize it. This is, very open notes, this class. It can be helpful to memorize it, but if you can find it and you know it exists, you know how to read the unit circle, you can just Google it and find that unit circle.